这个也挺奇怪的。对啊，我一开始比较定的。
There's the change, and Amsterdam literally broke down. Yeah, there's a fog in the channel or something. Yeah, nothing happened. So you have the pleasant to start your presentation, as you were supposed to be the last one. Yeah, now you're the first one. You've got 3 more minutes to be prepared. I quickly click you through this, which is also not working. Excellent. So this is why are we doing this and why it's happening. I told you that before. We're preparing for the hackathon. Once again, it's arranged by Dutch Chain. It will be the world's largest blockchain hackathon. Please do not miss it. We'll have teams there, and I will put the microphone to my mouth. And we have teams there. We have a track hosted. It's called Nature2.0, the unimaginable but buildable. You can find it also online on dutchchain.com. Go and check it out. This is the agenda that was supposed to be, which we can actually now say it's very interesting. It's very small because we changed it. Yeah, I'm happy to share it later in the meetup group. We have the speaker coming. They can introduce themselves. This Squiffer, I told you how to use it. And we also invented another great format. Yeah, it's called Wormhole. Last time when we had the first one, the plug-in, we realized people had a lot of questions. It's a difficult topic. It's a lot of personal feelings towards it. So everybody who would like to discuss deeper with every speaker, this is the Wormhole. There are drinks, non-alcoholic, where you can sit, yeah, and discuss and talk to the people. Yeah, so have that. Use the opportunity. The speaker will go in. Meanwhile, the other agenda will following. Yeah, so do it. And it's the picture for the Dutch Chain Hackathon. Mark your calendars and. That's it. The Hyve mind that was supposed to be Dimitri, and I'm gonna just give you the mic and the clicker that hopefully works. So welcome. Introduce.
So hi everyone. My name is Hyve. Does this work? Yeah, I'm Hyve. I'm the co-founder of Crya, and at Crya, what we do is we help organizations adopt blockchain technology. So we guide them throughout the whole process from the ideation phase to validation and eventually developing a proof of concept and then iterating upon it till we reach pilot and then actual production. We haven't reached production yet. We're still in a few projects in the pilot phase and we're still in the proof of concept phase. We take a platform agnostic view to use cases, so we don't commit to any platforms. We select the platform that we think is more adequate for the given use case. We're based in Amsterdam. We have our own development team in-house, and we've been around for 1.5 years. So that's enough about my company. I'm here to talk about decentralized artificial intelligence. So first, why do we need decentralized artificial intelligence? The problems with centralized artificial intelligence. So first of all, knowledge is decentralized, but AI is not. Knowledge, as we know it, is basically scattered around the world. There's no single person that knows everything. And it's through collaboration and sharing of knowledge is where we get where we are right now. And that is what brought us at the top of the food chain, for example. Close collaboration is also a limitation with centralized artificial intelligence. Basically, since all of the models and all of the data is being centralized, there's a limited amount of people that is actually working on artificial intelligence. So there's a lack of data for the startups that do have the capacity to apply artificial intelligence. And there is a lack of skill set for the traditional organizations that do have the data but can't apply the technology. So it's a monopoly game. Basically, rich get richer in a way. So only these powerhouses that do have both the data and capacity are able to use AI, and they enter this cycle of continuous feedback, which gives them the edge over everyone else. Other limitations with centralized AI is bias. Everything with artificial intelligence is based on bias. So you have data scientists, they pick the models, they select the data, and they train the data. And all of these basically lead to the bias of the data scientists that apply the technology are part of are the result of the computation that is done. So there's a lot of bias. And another is transparency and influence ratio. This is a link to an article about the CEO of Google, and basically he says that he thinks that the users of Android mobile devices are totally aware of the data that is being gathered of each user. I don't agree with him. I think most people are very unaware of the amount of data that's being gathered and the amount of knowledge that's being gathered from everyone. And there's no transparency of what they're doing with the data. We've seen a lot of political even movements happening online through manipulation and basically influencing the people without them even knowing it, because they know more than we do about ourselves. So what are the challenges with distributed AI? The problems that I mentioned earlier are possibly fixed through distributed AI, but we're still not there yet. And the challenges are, first of all, is an economic problem. How do you incentivize people to participate and collaborate? There was no solution a few years ago, but now with distributed ledger technology, we might be able to implement these incentives to basically incentivize people to contribute and to contribute in a decentralized artificial intelligence. Privacy is also a big problem. A lot of companies they would want to share their data to other data scientists, basically, to get more results out of it instead of just relying on their own internal team. But there's no safe way of sharing data, or there was. And another one is influence. Can third parties contribute to the behavior of knowledge in AI models in a way that is quantitatively influential? Basically, these people, they have all of the influence, and you want to have influence of the whole world, like I said, instead of relying on these parties and their biases to contribute. So the solutions, first of all, the economic solution, blockchain is a possible solution to incentivize people. For privacy, there are a few. So homomorphic encryption is one. Again, cryptography is also another one. Secure multi-party computations, and even zero-knowledge proof, but I didn't include it. And influence, how do you basically gather input from more people than just these central parties through federated learning? Big disclaimer, I'm not a cryptographer, so I'm just going to give you guys a toy box example of these solutions. So the economic problem, I might as well go faster this. We all know blockchain technology. Distributed ledger with nodes connected to one another. They're in consensus, so they agree on the current state of the network. And then it's an immutable ledger, so add only, and there's no tampering with the data being added to the blockchain. The privacy problem, homomorphic encryption, a mapping of mathematical sets into or onto another set of itself in such a way that the results obtained by applying operations to elements to the first set is mapped onto the results obtained by applying corresponding operations to their respective images in the second set. So what this means is that you want to basically encrypt the data in a way that allows you to do computations with it and then be able to decrypt it. So this is a really hard problem. I think the guys from Ocean can explain it better. But what you want to do is you encrypt the data in a way. So for example, let's say you want to do a computation of just adding a number. So your input is number 8 and number 10. and then you encrypt it, toy box example, you add 2 to each number. So you will get 12 and 10. And then you add them, and then you get 22 as a result. But that's not the same answer that you would have gotten without encrypting it in the first place. So once you did a computation, you get a result, and then you're able to decrypt because only you know the input or the random number that you added to the computation. I think that confused everyone. But yeah. There are a few applications or implementations of homomorphic encryption, and we have partial and full homomorphic encryption. The implementations with partial are, for example, unpadded RSA, LGML, and Palier. And for full homomorphic encryption, it's still pretty conceptual. There's no real implementation there yet, to my knowledge. And the challenges with it is that it's computationally heavy. So the amount of computation needed for simple computations can even be to up to a year of computation. And that makes it, for now, unfeasible to apply. But it's still in its infancy in the space. Another approach is the generative adversarial neural networks, or GAN. The idea behind it is you have a generator and you have a discriminator. So one example would be you have a generator that basically generates new images and a discriminator that is able to tell whether an image is real or generated. And you apply machine learning models on both ends. So basically you have a continuous feedback loop of better generations and then better discrimination. So they keep on providing each other with feedback and creating better results. So with cryptography, what this means is you have, for example, Bob and Alice. They want to send a message to one another. And you have Eve that wants to eavesdrop on the message. So you want to apply GAN to this problem. So what the generator part is Alice and Bob are gonna generate their own encryption schemes, and Eve wants to basically intercept and decrypt those encryption schemes. So this is done without any input of previous encryption schemes. So they basically start from scratch, generate some encryption, get feedback, update it, and vice versa. So you have this continuous feedback loop of coming up with new encryption schemes. And secure multi-party computation. So the idea behind this is you want people to provide input data in a, let's call it a black box, and they want to get the result out of it. So you only know your own input and you only know the output of this algorithm. So one example would be, let's say Eve, Bob, and Alice want to compute their average salary. So you start with Eve. Eve adds her salary plus some random number, and then passes it on to Bob. Bob adds then his salary plus some random number, passes it on to Alice. Alice adds her salary plus a random number. So now you have a sum of all of the salaries plus a sum of all of the magic variable numbers. So that gets passed on to Eve, and then Eve subtracts her magic number, passes it on to Bob. Bob subtracts his magic number, passes it on to Alice. Alice subtracts her magic number, passes it on to Eve. So now Eve has the sum of all of the salaries without knowing the salaries of each individual person. And if you intercept any of these messages being passed, you still have no information about the salary itself. So now Eve knows the sum, and she is just able to divide it by 3 and figure out the average salary. And Bob has to do the same, and Alice has to do the same. So all of these guys basically know the input and the output, but none of the other inputs of the other parties involved. There are a few projects working on this. I'm familiar with Enigma that is doing secure computation, multi-party computation, and Oasis Labs. So there aren't that many, and it's still up and coming. And the influence problem. Basically, you want to get influence of everyone around the world instead of these siloed data scientists. And one solution is federated learning. Federated learning is first proposed by Google. And the benefits of applying federated learning is the data or the input is kept secret. And another is the distribution of the computation is also a beneficial factor instead of doing it all in-house. So how does it work? So you have all of these parties basically providing input, or traditionally how it would work is you have all of these parties, they have their own input, and they do a computation on their input, on their own device. So they don't send it to Google, but they compute on their own device. The output of that, that's what they send to Google. So now you have distributed computation. You don't need powerful machines centralized in one data center. And the input is unknown. It's just the output is given. And also the gathering of the data it doesn't gather to one centralized point. So you have distributed computation and distributed, basically, input of the data. And then the output gets sent to Google, and then they can use it to improve their model. So you want to distribute this. So basically what you do is the same, but instead of sharing the output with Google or some party, you share it among the network. So this way you can create some collective intelligence within the network instead of having some centralized party that is the only person that knows the output of these models. So that was the solutions to all of the problems that we had. It wasn't possible until a few years ago, as we know, with all of these new technologies. The idea existed, but it wasn't possible to apply. But now it's becoming increasingly possible, and hope to see some cool solutions. So last, I want to end with a project that we did. So we participated in the hackathon this year in April, where we came up with Grex. The idea behind Grex is to combine swarm robotics with blockchain technology. In traditional swarm, you have each agent only knows about local knowledge, so what it can observe and what it can communicate with adjacent agents, but the global knowledge of the network, so what do they do, what is the goal of the swarm, these are all managed by a central authority. And by combining swarm robotics with distributed ledger technology, you basically gather global knowledge within the network instead of relying on that trusted third party. So we developed a really simple proof of concept of the idea, where we had multiple machines. So we had simulated drones, which are the yellow dots. We had beacons, videos, energy stations, and repair stations. And it is when you combine all of these elements together, you can build basically a self-sustaining ecosystem of autonomous machines that are able to execute different types of mission. And we focus on search and rescue. So first you have the exploration phase. So the drones basically move around, try to find someone in need. And then one of the drones basically detects that someone is in need. So the orange dot is a drone that detects someone that is in need, and what it does is it propagates a transaction to the network, and that gets picked up by other machines in the system. So the scouting drones aren't able to help the person itself, they only detect where it is, but that triggers a transaction which is propagated to the network and gets picked up by the one that is responsible for executing the rescue mission. So we build it. Last step, convergence. So once it's detected, the other agents basically move to help the person that is in need. So we developed this proof of concept, and we've put it open source online. And the idea is that it's just a basic framework for you if you want to do some experiments. So you might be able to change the blockchain stack that we used, or you might optimize the search algorithm, because now we just used a random walk. We had 2 days to implement it. But you can just use this, build your own experiments, and it also has a nice interface which gives you basically overview of your experiment. So check it out at github/crya/grex, and hope you guys build some experiments with it. Thank you.
Okay, that was perfect. Now has come this amazing wormhole session. So if you have questions, you can ask there. And I am pretty sure we have Dimitri now coming up, but pretty sure is not so sure. So if you want to do the Q&A now, it would be a good start to do that.
Sure.
So there's a good person for a good question.
Yes, I have a question, or probably rather a hint. There is a company called InfoShield in the United States who have done a pretty good case on full homomorphic encryption, and I think you should take a look, because I think it's maybe it's not fully mature, but it's not only on a concept stage. Definitely not.
Okay.
I can send you a link.
I'll sit next to you in a bit. Any other questions?
Ask a question.
How far is this from the 70s theory of swarm intelligence and swarm particle behavior? Like previously, like how far ahead is this in terms of, you know, previously were calculating means regarding to the perturbancy coming into the system to each particle?
I'm not familiar with that.
Okay.
So I can't compare it.
All right. We can have maybe a talk later on it.
Sure.
Okay, there's the thing. We have our second speaker, Trevant, and he has his Christmas party. So there's a lot of dedication towards the topic of Nature 2.0 because he's skipping free drinks and food. Yeah, and as an executive decision, yeah, please welcome him on stage, and we keep on going with the program. And we're still waiting for. Oh no, we are waiting. Not come on stage. Yeah, so. We call it fast iteration, yeah? So, you do that, I get your presentation, yeah?
Thank you, yeah.
And it's nice, it's Polkadot.
Yeah, that's nice, that's Polkadot, that's what I want to talk about. So my name is Thibaut Sardin, and I want to talk about Polkadot and Substrate. Before I do this, I would like to know who of you has heard or is familiar with Polkadot. Can you raise your hand? Awesome. And so for you to know, it's like 20%, 25%. And who of you is familiar or heard about Substrate? A bit less than the 20% before. So I will try to not go too fast. The things is, those two things are really big. Like it's two big topics, and I will just scratch the surface. And if there's anything that you're interested in, I'm happy to dig in with you in the questions. So first of all, I will start with this statement that specializations breeds optimization. This is something that I think is actually very general, not only applies to blockchains. When you do one thing, and you do only one thing, usually you optimize it. You spend a lot of time on it, or at least enough time so that you're happy with it, and you optimize it. And when you try to do several things, like a lot of things at the same time, or try to cover a broad scope, then you might maybe not optimize it as well and not do it as well, as good as if you had several people doing one simple thing. And this is something that we keep in mind, and we had in mind from the beginning, from the start when we started to work on Polkadot. What we've realized is that today we have so many different blockchains, and many blockchains do try to do a lot of things, and some of them try to do also one thing. Let me take an example like Zcash, right? Zcash does one thing very well, or try to do it very well. It's like privacy, trying to send some Zcash over without knowing how much is sent and who has sent it, etc. And the thing is, we see a lot of blockchains that try to do a lot of things, and the problem is, well, it's not very optimized, and there's not one blockchain that achieves everything. You cannot have like a very good privacy and, I don't know, like smart contracts, for instance. So this is a problem. And all of these chains that we see have very different objectives and very different state machines. Just realize I'm actually standing in the way. You might not see me. Should I stand here?
Stand
but
perfect.
Then I'm far. Yeah. Okay. So these, what we call state machine, I will talk about this word a bit more after. It's really what makes the state of the blockchain evolve. Why Bitcoin block can have some transactions and why it evolves to another block, why are transaction accepted, etc. in a block. And so, as I mentioned today, I feel like we have a lot of different blockchains that are doing different things with different state machines, different consensus, but they're all like bubbles, like these bubbles. They really don't interact with each other. They don't know about each other. Maybe the developer who built them know a bit and try to take smart things from each other, but like when you're on Bitcoin or on Ethereum, you cannot really talk. Like Ethereum has some cool things that you can do, such as bridges, but it's still like it's always, you always have to go through a centralized, like kind of a centralized entity to move from one chain to another. So in the end, we end up with a bit with, oh, Dimitri is there. Awesome. So you end up with kind of the silos that we try to actually escape with these decentralization. So we really need, what we really try to do is solve this problem of interoperability with Polkadot. We really need interoperability, we really need these blockchains to talk to each other. And yeah, so that's Polkadot. For those of you who don't know what it is, actually I think I have a slide. Yeah, exactly. It is a protocol that allows independent blockchains to exchange information. So, yeah, think about it. So it's, I mean, yeah, I hear about it every day, so I know what it is, but I feel like the first time I heard about it, it was actually not very clear what it was. So protocol that allows independent blockchains to exchange information. So you can think about these different blockchains like trees in a forest, and those trees don't really talk to each other, they never connect, and you will have this protocol, this Polkadot that allows actually those blockchains, those trees to be connected, like on the ground, for instance. And so it's the same, but said differently. It's an interoperability layer that enforces order and the validity of messages between the chains. So it's basically a way for several different chains to talk to each other, to exchange messages. How do we do this? So it is yet another blockchain that kind of allows us to do this. So if you see here, there's a big relay chain in the middle, and this is a blockchain whose purpose is basically to exchange messages between other blockchains. And these other blockchains, the trees that I was talking about, were those parachains. So as you can see, they are a bit different. Like each parachain is different, and we want these parachain to do one thing very well. So we really hope that we will have one parachain that is very good at privacy, one parachain that is very good at, I don't know, like maybe a smart contract, or one that is very good at doing some identity things. And this relay chain in the middle, it is a blockchain that allows to send arbitrary messages between those different parachains. And because we don't want to just forget about what we've built before, meaning Ethereum, Zcash, etc., we might for some parachain, we might for some blockchain be able to build a bridge, such as here for Ethereum. It's quite easy actually, because Ethereum is has a Turing complete virtual machine, so we can do almost anything we want. So we can build a bridge to this Polkadot ecosystem. The whole thing is the ecosystem. I forgot to click. So the relay chain in the middle, the parachains around, and the bridges to interact with third-party chains that were built before Polkadot. So one thing that Polkadot brings, which is really awesome when you want to build your parachain, it is what we call pooled security. Today, when you build a blockchain, you have to build the whole community to secure your blockchain, right? When you have like Bitcoin, when you have Ethereum, or here I took as an example Litecoin and Zcash, you have to have like, for proof of work, you have to have some miners. You have to have a community of persons who will dedicate some mining power. The thing is, they cannot, like if they try to secure Zcash or if they try to secure Litecoin, they cannot do it at the same time because it's proof of work. And actually, because they spend a bit on Zcash, they are actually lowering the security on Litecoin, which is really sad. This is something that we can solve with proof of stake, and that's what we use on Polkadot. So basically, when you come and build and connect your blockchain to the Polkadot network, when you come and add one of the trees to this forest, you will benefit directly from the security of the network, meaning that the validators, these guys on the top, they will share their validating power. I don't know how to say this. They will basically share their security. The security will be shared among all the blockchain that take part in this Polkadot network. So when you come and join Polkadot with your blockchain, you do not have to bother about security, because this is something that is provided by the network. So we really want to be inclusive here and connect the dots or the bubbles. And yeah. So there's one thing that we did when we built Polkadot. So Polkadot is a project from the Web3 Foundation, and they have basically asked to Parity, or like one of the founding member is the same in Parity and Web3 Foundation. We've been basically asked to build the first implementation of Polkadot in Rust. And Parity Technologies has been building blockchains for a while already. So the funding members of Parity actually built the first C++ implementation of Ethereum. Then they built it in Rust, and then we also built a Bitcoin implementation, which is called PBTC. And recently, you might have heard that actually Parity will be the Zcash implementation also. This has been asked by the Zcash Foundation. So we've been doing this for a while, building blockchains, and it's kind of all the time the same. You have to, like, it's not copy pasting directly, but you have to really do the same things. Like, you have all the sync to care about, the networking. It's done on dev P2P on one side. On Polkadot, we use libp2p. You have to build, I don't know, all the CLI, all the RPC, all the storage, and you just redo it all over again. And because we've done this for a while, we have a lot of knowledge on this, and we thought, okay, now we're going to build, for instance, for Polkadot, the relay chain, and we're going to do it again? No, not this time. This time we're going to build a framework to do it. So that's Substrate. So Substrate is very, very different than Polkadot. It's like Polkadot is the network to connect parachains between each other, and Substrate is really a library, a framework. Actually, I have a slide for this. So it's a general purpose blockchain development kit, and it's written in Rust because everything we do at Parity is Rust. So this is really kind of, a framework to build blockchain, but not only for Polkadot, and that's the really interesting thing. You could use this today to build your own chain. You do not have to build it with Polkadot. You can build your community and care about, I don't know, security and stuff. Even though Polkadot gives it to you for free, you can kind of use Substrate to do your own chain. We call it solo chain, and not plug it into Polkadot. And so what Substrate does is giving you all these tools that I was talking about before, and I will mention them right after, that you kind of have to build them anyways if you want to build your chain. It's just that they are here and given away for free. So when you think about blockchain, I was talking about all these different blockchains before. There are a couple of things that make one blockchain very different to another. One of these things is the consensus. So it could be proof of work, proof of authority based, proof of stake. Basically, this is what makes, for instance, I don't know, like EOS very different from Ethereum, because one is dedicated proof of stake, the other is proof of work, and this is like some kind of also marketing scalability marketing language. There are a lot of things that go into this. There's also what I was talking before, the state machine. So this is really why Bitcoin is Bitcoin and why Zcash is Zcash. I mean, in the end, you're sending tokens, right? But why is Bitcoin Bitcoin? Well, because it's based on, I don't know, like UTXO, and because you can like aggregate some different UTXO and say, okay, I want to spend this. Or Zcash has all these privacy and ZK snarks. So this like consensus state machine is something that you kind of have to build. Like if we give you the tools, Substrate, to build your own blockchain, you still have to kind of build what makes your blockchain unique, right? And this will be in the state machine, for instance. So now I'm going to list all the things that you get with Substrate. So one thing which is a bit complex to understand, it's called SRML. It's for Substrate Runtime Module Library. And it's a set of library, a set of tools, a bit like, think about it, just like Lego. You can just take it, a library, take it, plug it in, and it should work. So there's this, of course, interconnection between chains that you get out of the box, because we built Substrate for Polkadot, so you get it. And it means also that if you use Substrate, you will be able to plug it to Polkadot, your parachain, or your chain, sorry, you can plug it to Polkadot very easily. There's a hop-swappable, pluggable consensus. I was talking about consensus right before. What makes a blockchain very different from another is very often the consensus. Here we have a pluggable consensus, meaning that you can use kind of the consensus that you want. We do have a couple consensus built in already. One is called Grandpa. It's a bit like Casper with like some block production decoupled with the finality gadget. I will not talk about this, but we have interesting things online if you want to hear more. And then there's the light client, meaning that you can have, for instance, mobile to sync with the top of the chain quite easily. Right now, having a full node is already for, if you heard about Ethereum, for instance, that, I mean, apparently we're building a full node for Ethereum. It's really a pain in the neck, and you definitely cannot run it in a mobile. If you use the light client, however, even for Ethereum, you kind of can already use it. And we give it for free also with Substrate. There's exchange synchronization, the PubSub to build UI on top of it, transaction queue, the networking, which is built on libp2p, so it means that it can be implemented in the browser pretty easily. On top of the Rust implementation, sorry, that's a long list, that's annoying. On top of the Rust implementation, there's a JavaScript implementation also. There's telemetry, which is basically a way to see which node is connected to the network, etc. And last but not least, I will spend a bit more time on this one, a breadable runtime, chain runtime. That's a very fancy name. We couldn't find a better one, actually, so I will spend a bit more time about this right now. What does that mean? So runtime. First, I will try to talk about this runtime. So runtime is really like a bit like the state machine. So it is the software that will understand all the transactions that come in. For instance, I was saying Zcash. In this software, in the core of the Zcash blockchains, it knows She said I have 5 minutes. I'll try not to be too quick, but that's fine, I'm pretty sure. So it knows basically for Zcash, okay, how to validate Zk snarks and how to know that you are actually the person you pretend you are and you have the money you want to spend, etc. So this is the runtime. This is the core of the blockchain. This is what knows how to go from one state to another, which understands the transactions that are sent around. And the runtime in Polkadot and in Substrate has to be written in WebAssembly. I will go pretty quick on this one, because if you don't know what WebAssembly is, I'm pretty sure after my talk you will still not know what it is, and that's okay. So it's a really clever thing that runs in a browser and is extremely quick. So it can be built out of C, C++, and Rust. So basically you build your program in C, C++, or Rust, boom, you compile it to WASM, and WASM is awesome because almost everything can be can run this binary, this executable. And the runtime I was talking about has to be built in WASM. So basically, you build it in C, C++, Rust, and you compile it to WASM. So hot upgradable runtime, I was saying. So this runtime, you have to build it. That's the thing that you build. We give you like everything that's around, and we let you build the runtime because that's what makes your blockchain so unique, right? And it has one function which is exposed to the outside, to the substrate, and that's execute block. And this function is really cool because it can allow you to upgrade itself. So basically, this WASM runtime, what you have built, you can basically tell itself to, okay, starting from next block, you will not use this executable, you will use another one. So you basically replace, a bit like, I don't know, you know when you upgrade, or you don't even see it, right? When you upgrade your browser, Chrome, you just shut it down and turn it on again, and then it's the new version, you didn't even see it. Okay, this can happen without shutting it down and turning it on again with this hot upgradable runtime. And we did actually use this when switching from our proof of concept 1 to proof of concept 2. So those are testnets that are live today already. And we did use this, so we did an on-chain upgrade. I have probably 1 minute for this one. But it's actually really interesting to understand, okay, how do I do when I have so I have nodes that runs this blockchain, and today we have a lot of problems when we want to upgrade the blockchain. We have all these nodes that needs to be upgraded, to be updated. And we have really fancy way, because it's WASM again, because it's so cool, we have really fancy way to actually make sure that all the nodes, even the old ones, can run the latest WASM, the latest runtime, the one you want to upgrade. Basically, this will happen this way. The client, the node, will always ask on the chain, okay, what is the latest runtime? And this is stored on chain in WASM. If you have natively the latest, then you will run the native one, so it will be very, very quick. And if you do not have it, you will run the WASM one, which is stored on chain, which is quick, but not like awesomely quick. I think that's it. If you want to know more, parity.io/substrate, and yeah, I'm here still for questions in this wormhole thing.
Hey, thank you very much. So, there's good news. Our friends from Amsterdam finally made it. But I think anybody has questions? Because I think it was, yes, you have.
Hey, thanks for the presentation. You're trying to build an encompassing relay chain, like connecting all the blockchains. So what you're trying not to do is that each of the blockchains out there are connected to each other, but they're like centrally connected. And you have this pooled security, right?
Yes.
So isn't there like a huge centralization risk? Like, for example, if the consensus on the relay chain is broken, I mean, I guess there could be some attack vectors to the network, or the random number generator is broken. Wouldn't that mean that all the other connected bridge chains and parachains stop working?
Absolutely. So it's not because the relay chain is broken that the private chain don't work, but if the relay chain is broken, it doesn't relay anymore the messages. So this is a very good question, and that's something that I also ask myself when I say, hey, we see so many different blockchains and they don't talk to each other, and or when we say, okay, they are trying to do everything. Well, Polkadot is not trying to do everything, but it's trying to let people do one thing and allows people like the whole to do everything, so to say. So this is a very good question. We have like fail-safe. We have governance on top of this relay chain so that people can vote, people can propose, and we have like, this is actually very complex. And we really hope, like we have fail-safe also, like if we, let's say, break the relay chain because we did a hot upgrade and there's nothing is working anymore. We have some kind of fail-safe so that if no block is created, for instance, in the next 2 minutes, even though you have a 5-second block time, it will, for instance, roll back. Yeah. So there are plenty of clever things that we could do. If we kind of broke it, but not totally, maybe we will be able to hot upgrade again to fix it. So this is like, come and break it, please. We have a testnet for this.
Okay, I'm going to get you off stage. There's a wormhole session if you want to speak to him. Remember, he's got his Christmas party going on, yeah? And he probably wants to see all his lovely colleagues. If nobody wants to follow you, I suggest don't be a loner, yeah? Don't be a loner, come join us, yeah? Perfect. So this is Dimitri. It's like waiting for a rock star coming on stage, isn't it? A little bit. What was the worst concert? How long have you been waiting on a concert for? It was a question for a rock star to come up. Dimitri took 1.5 hours. Yeah, I think it's pretty good. That's about the time of being a rock star. And the good thing is we have no sound.
At that point in time, how do we trust that that robot actually makes the right decision and runs the right code?
Okay.
You could say, well, it runs on 10,000 similar robots and they all have to agree, and then that's the thing that a robot would do. Or you use this WebAssembly thingy and the robot runs its code in this special format and gives you a proof that it actually did it. At that point in time, you're quite sure and know that, oh, that robot did its job well, and now we can reward it, or we cannot. So, yes. We are ready? Yes. There is a beer and the water here. Oh, well.
And JP, Owen?
Ja? Genau. Alles klar? We are on the internet. Perfect. Hi everyone, and the people that I cannot see because they're in a different country. My name is Dimitri. I'm from BigChainDB and Ocean Protocol. And today I'm going to keep it quite short from my side because I already tired the people here in Amsterdam. And I'm just going to explain a bit what we're trying to do with Nature 2.0, what this exact session is about, or should be about, or at least we try to frame as such, what we did in the previous session and what we're going to do in the next session, and then leading up to the hackathon. So, an overview. This is what we've done last time. The blue thing, the Hive mind, is what we're going to do now. And self-actualization is a workshop on the 6th of January, I think. JP? The last... January 16th. January 16th is then the next one, and talking about self-actualization, and then we're also looking more into the legal side of things. How can we put these machines in a legal vehicle? Right. So I'm going to give you a bit of a recap of what happened in the last session, the plugged-in session. Oh, maybe just to show you, like, this was a bit of my thinking like to not make it too complex because there's a lot of steps you can put in between. But what I was thinking was, well, if you create something like autonomous resources and decentralized autonomous nature, you might follow a bit of a methodology. And this is just one proposal. First one is plug in the machines. Make sure that they all have a wallet and everybody's equal. And everybody can do transactions, whether you're a machine, whether you're a DAO, whether you're a DAO governing a resource, whether you're human, we all speak transactions and wallet. So this plugged in, it's basically is like retrofitting existing devices, hardware, software, and they all speak transaction. The Hive mind is, well, now we have these agents in the system defined by a wallet, and the Hive mind is now going to look at coordinations. So we have Krya, we have Oddbot, we have other people in Berlin, and they're all going to give us their ideas on how to have this coordination between those machines, and maybe they're even looking at empathy or ethics at some point, I think. And then one step further is self-actualization, and that's basically saying that, well, how human can we make these things? Can we have encode a few interesting laws or ethics into these machines? Can we type them into legal code? So what happened last time? We had so also this is a series, 3 series where we deeper into the technology as well, such that this all leads up to a hackathon, and the hackathon is gonna be the blockchain church hackathon. I guess it's in Groningen every year. It's really big, and it's a lot of. You can see how much fun the people have. What we want to do is we want to make sure that everybody understands the concepts that we're talking about. A little bit of a feeling of the code because so many things are happening in the space. So a bit of like saying that this is useful, this is not useful helps. And also just meet and talk with us and give us new ideas. So on the 28th of January, another important date, and you can start subscribing with teams towards this Nature 2.0 to participate in the hackathon. And there's a lot of really cool bounties attached to it, a few special treats that we have for you. And in the last session, we were looking at a few technology providers. One of them is Interlinked. Interlinked is all about digital twins. How can you create digital representation of a physical thing? Our digital is everything we gave to Google, basically, and they now have our digital twin. But a digital twin could be, for example, for a robot, could be a trace of all the things he did, all these actions, maybe in a provenance graph. That could be the digital twin of a robot. And interestingly, if you have a digital representation for a physical item, you have this one-to-one mapping, and you sometimes need to have special hardware to do that. So this hardware can be provided, and we have a few really cool companies doing so. One of them is called Weave.network. And Weave is working with secure operating systems. What does this do? This means that you can have a little device. It's an ARM chip. I think that's in most mobile devices available. And there is something called a trusted enclave. A trusted enclave is like the secure box within the hardware where nobody can look into, and the only thing that comes out is correctly run code together with the cryptographic proof that that code got run. So you cannot cheat the device. You cannot spoof the device. You cannot create a clone of the device. There's only one device, and that's identified by that secure hardware. And Weave provides you, well, it's common hardware. Everybody kind of have it. And they give you like this nice operating system to manage the secure enclaves and stuff. So their code is on GitHub. Basically, one of those embedded devices. And it has a lot of, it's like this, you know, this running robot, and it has a lot of, way too many cameras. It's a bit over-engineered, but it also has artificial intelligence on that embedded device. So what they do use it for is races. So this can follow a track. I think Oddbot's device can also follow tracks. It basically can run around and race against others. And all the artificial intelligence is on the robot itself. So it doesn't have to compute in the cloud. It's all compressed onto the robot. So with that, we can all make a lot of fun toys already. Today, we'll be looking more at global systems, like, for example, decentralized energy, or grids, or maybe even that TerraZero thingy. And we're looking less into a single agent, but more like groups now. And that's what we're trying to look for today. Also, there is this pyramid of Maslow that I think that kind of maps a little bit to what we can do. This is kind of saying that in order to become a self-actualized being, you need to have a few layers of activation. At the lowest level, you need to have your physical needs, like food, water, shelter. One layer above, you need security. You need maybe legal status, other kind of safety needs to survive. And once you know how to survive, then you might want to create social circles, communities, friends, empathy, and then you maybe want to go one step further and have this form of self-achievement and doing something for your community and becoming more active. And in the end, you could say there is a layer of intelligence. And for each of these, you can actually start designing for agents, how would that look like? Can we create some form of API or some form of minimal code to experiment how machines could express empathy? For example, if a machine can ask another machine like, hey, what do you need? Okay, I won't touch that. I give you the space to operate right there, for example. So a lot of experimental stuff. I think the slides and all of these things are on the website. Otherwise, we will put them there. And then in the previous session, we went over each of these them, and we kind of gave a hint of how would this look like. Now, today, I'm going to give a little bit of an overview of how we can help with Ocean Protocol ourselves. I'm at the research side of things, and with Ocean Protocol, what we're trying to build is something like a public intelligence network. You could call it a machine learning marketplace or a data marketplace, but in the end, it should be a public marketplace, a public network with a lot of free data, a lot of free AI, not owned by big companies. But everybody has access to that artificial intelligence. That's what we're trying to do. And to give you a bit of an idea, think about this is how we model the world. This is all we need to know for Ocean Protocol to model the world. We want to create something like decision-making trees and supply chains for machine learning, and it's always the same thing. You have data, you have algorithms and data come together, they compute something, and that compute could be a prediction, could be a classification of things, could be a lot of interesting things. For example, let's try to build a virtual human agent. This is actually something we do with a Japanese company, Cougar. And yeah, they make manga stuff out of everything, but they have this virtual human agent, and it has a few. So this is like this digital agent, and it can jump from screen to screen and interact with you, and actually knows what's happening in the room and react to it. How does it do that? Well, first of all, it needs to know what's happening, so it needs to look around. It has camera images, and then it responds to speech. in order to have something that can detect objects, you need a lot of image data that's labeled and saying this is a dog, this is a chair, this is a thing. And if you have many, many of these things, you get basically, you can have a computer classify images that it hasn't seen before. So if it sees 10 chairs, maybe at IKEA or what have you, from the catalog, and then you have a chair that's, you take a picture from here, and then the AI can quite well predict that it's also a chair, given on those 10 chairs it has seen before. The same for speech. Speech will then go into natural language processing and gets context attached to it, and then you have your chatbots and all these things. So creating a virtual human agent is basically a data supply chain. The supply chain going from labeled data, from unlabeled data, etc., and then basically goes into these things called neural networks. Interesting neural networks are convolutional neural networks. They can look at images, they can look at speech, they can look at other things. And then if these things come together, you basically have something that can predict objects, classify objects, predict speech, interact, etc. So what we're thinking is, well, if you create a blockchain version out of it, then one of the things you're going to do is saying that, well, everything here, every component is a service that we want to offer to an open market. And if you want to interact with that service, you have to buy the contract of that service. So on the internet, there is this thing called service level agreements, saying that Amazon guarantees you that 99.99% of the time they will always be up. If we go to work and then sometimes Slack or GitHub go down during the operational day. So if Slack goes down, we have no communication with the team whatsoever. If GitHub goes down, we cannot communicate across code. So service level agreements allow these services to basically, well, they allow mutual protection, saying that if you don't deliver the algorithm, then you're not going to get paid or you might get penalized. So it basically says that all the people consuming these resources are protected from both ends. And we have flexible contracts to do so. So what we really want to build is not just one service in each, but basically a multitude of services. Saying that you can have open markets. It's not like a big supermarket. It's going to be more like a bazaar where everybody that has something interesting can push it to the network. If you're a data scientist late at night at home and you build this amazing neural network and you say, well, I'm just going to throw it on the market, see if I can make some money out of it. That should be possible. If you say, well, this is cool for the community. It's something that I want to give away for free. I just want to get accreditation. That's also possible. And we don't model as such as a really economical marketplace. It's more like a tribe, problem-solving tribes. So just to give you an idea, there's a lot of existing services and new services that are emerging into this data science market. And we have big cloud providers like Amazon and Azure. We also have decentralized prediction networks like Numerai, SingularityNet is a marketplace. We have specific type of privacy-preserving computation like Enigma. We have Truebit. There's so many things that you kind of want to connect into full supply chains. You don't not only want to use the computation here, but you want to also connect it to the next one and the next one and the next one and create like full solutions with data science. And that's what we try to solve with Ocean Protocol. Basically create a graph, a data pipeline, a supply chain of intelligence. And not just because we can, but because we think that if you put in the right incentives in this system, you're going to create data supply chains that can solve problems that are related to long-living problems like sustainable development goals. We think we're trying to set something up that's called AI for Good, AI Commons, and ImpactNet. And that's basically saying that people can post problems in this network, and they have a bounty attached to it. And if you find a data service supply chain that can solve the problem, you basically win the bounty, and then the question is what kind of problems to be solved. A few of the problems to be solved is, for example, looking at how can we measure coral bleaching in the oceans? How can we predict, for example, and that's a really cool one. There's a lot of health companies and universities and hospitals that are gathering a lot of data about skin. And sometimes you have a mole on your skin, and most of the times that's not a problem. In a few times, that's actually a malicious tumor, so skin cancer. So what we're looking at is, can we make an automatic classifier that you just take a picture of your skin, you upload it to the network, and if it's robust enough, it won't give you false positives. But it could assist and proactively early warn people that you might have a problem. So this is that's an interesting project. And other projects are around, let's say, autonomous driving, for example. We had a few others. And what we're trying to do is set up this type of tribes and communities that basically govern their problems, they put funds in it, and they set it up as a bounty, and then people, data scientists, and data providers can work in this network, and they can try to solve these problems and get rewarded for it. So one of the things we're working around is Mobi. We have a very big prize around autonomous driving right there. If you go to Mobi network, then you can see what that exactly means. This is, I just talked about that. That's the healthcare example. Other things that are fun is to look at, well, now you have all these assistants. You have Siri, Alexa, you have your Netflix recommendation engine, and you maybe have your vocabulary, etc. And they're all owned by different services. Is it possible to basically collect your recommender or your assistant on your phone, carry it with you all the time, and learns about everything you do fully horizontal, but never gives it away to somebody because it stays on your phone? So then you really get your digital assistant next to you. And maybe we can look at what collective intelligence can do. But that's something I will leave to the guys from Crya to figure out and to indulge us. Those communities themselves, well, we're working a lot around decentralized autonomous organizations, which I can explain before. Typically, it's about crowdsourcing and crowdfunding, a DAO managing resources, meaning that there's a set of people that can vote how to spend. TerraZero connecting this DAO to natural resources, and there's even something called plantoids. This is from an artist, Primavera de Filippi, and she makes this. Basically, you have to interact with this blockchain life form, give it a bit of money, and then it will try to gather enough to create a brother, and then create a family and a community, and just wants to replicate itself. Now, that's it for my talk. Actually, what we want to do is make sure that people here also know a bit about what you can do with Ocean. Here we have, maybe if you want, you can send an email to raindrops@oceanprotocol.com. And now we're just airdropping a few of our tokens, such that if we go live with the network, you can actually play around in the system. And we want to give community members a bit of early mover advantage. So if you, by tonight at 11 p.m., send an email with the subject HiveMind to raindrops@oceanprotocol.com, we can figure something out to reward you guys. So yeah, I guess that's from my side. JP, do we have time for questions? Do we go to the next talk? We have time for questions? If there are any questions.
You showed something about curating the results of those
Yeah.
compute steps. How do you going to incentivize the curators to do a good job?
Yeah, that's actually a good question. Curation is very important because it allows to separate the signal from the noise, the important stuff from the unimportant things, the relevant from the irrelevant. And it's very difficult to incentivize it. You have to make low friction, and typically we're looking at how, if somebody bets on something first, how can you have others? But actually, to play with this, I might have lost the live stream, but we have this website called musicmap.info. And what we're designing in the back, it's not yet hooked up, but this is basically, we try to build a history of music genres, right? So here you see, for example, the 1900s. Here you have the 2000s. This is blues, jazz. Here we have EDM emerging. We have some early electronic music. We have rock and roll going into contemporary rock and etc. Right? Well, the fun thing is you can actually zoom in into this map. Whoops. And then you see distinct genres. Right? You can see where they come from, where they're going to, what influence what. And the fun thing is you can click on them. If you click on them, you get a bit of like Wikipedia-style text around it. But the real fun thing is that you also have a playlist. So for each of these genres, and then you can have like visual discovery of music. Yeah? And what we really want is to have every song in the world classified in this universal map of music, but it has to be community curated. You can imagine, I don't know who here is a ska, punk, ska core fan. If I put this on and if there is a fan in, he would say, that song shouldn't be there, that one should be on level 1, and everybody has an opinion, and some of them have more opinion, and now we can play interesting games. How can we maintain the lists here, curate them? Because here we're doing a simple machine learning task, a data engineering task, actually. You say, take a song, which kind of zeitgeist, genre, can we attach to it? What's the community consensus around this? So we're bounding out all the steps of making this, because we have to do some other stuff in the meanwhile, but we're bounding everything out, and we have all the designs ready, so people that want to, within a month or something, all the little steps on how to build the system together with us, it's going to come online. And then one of the cool things is that we created a gaming engine, which is just about the incentives. And now we play a few interesting games, like you can earn badges. You might be able, if you're the king of the genre, you might have a few permissions on how do you want the genre to be exposed to the outside world. Do you want to have like a special background? Maybe you want to have your face up there, have a bit of attention, what have you. We can go as broad as you want, but a lot of fun stuff there. So does that answer your question a little bit?
Yeah, a little bit. I like the concept a lot. It's nice that you show that. So you try to focus on the emotion of people, actually.
Well,
because
yeah.
If you can do you can pinpoint any song into any genre if you like.
Please repeat the question for me.
I'll repeat the question. So the question is if we're talking about emotion and opinion and a very subjective matter, and we want to put this into a system, and who's going to decide what's the actual group opinion. So for this we use, you can use a few interesting token games.
Like what?
One of them is called token created registries. And that's basically, it's a zero-sum game that says that if you put your proposal on there, people can vote on the proposal. Before you put your proposal out there, you say that I'm going to back it with this amount of tokens. Community does a round of voting. If they agree, you keep your tokens and your things come on the list. If they disagree, they slash your tokens and they divide it. But when they vote, they have two camps, and the losing camp also has to take per vote 1 token, and they lose their votes. And the other
Shelling point.
is shelling point, exactly. Yeah. Yeah.
Okay, nice, thanks.
All right. I don't know if I'm plugged in, but so this will be the end of your presentation.
Very good. Very
and
good.
of your time. We will now have a 10 minutes break. for you as well to rest your minds and your brains. You can use this time to, of course, take some drinks and some pizzas. And the bathroom are on your right. Is that me? On your right when you get out down the stairs.
There's
And
also this wormhole thing.
this wormhole thing, we'll take care of that afterwards.
That's afterwards.
For now it's the break because
I
that's
close that
mention the
because we have
wormhole.
10
Yeah,
minutes
yes,
break as
okay.
well. Yeah.
Good.
I'll have to rest myself and get a beer. We have 2 more presentations. Yeah, it's one about the Hive mind. We have a live streaming, and I promise it's still working. We saw that. Yeah, it's functional. And we have Livu finishing. Please stay. Pizza is gone, but drinks are endless. Okay, and we start at 20:42 sharp. Okay, thank you.
I'm against. You thought like these.
Genau. Das ist ja. Also zumindest validiertes Transaktion, Interchain-Transaktion, aber. Genau, aber der sagt, wenn die Village steht, ja. Ja, genau, das ist die Idee, ne? Aber das Ding ist, wenn sie ihre Sicherheit abgeben zum Teil. Zum Beispiel, du hast eine Relay, eine Parachain, die vielleicht nur einen Wert von 1 Million hat oder noch weniger, dann hat sie halt nicht so sicher. Achso, das ist ich glaube, eigentlich sollten die Sprecher nachher in Talks da rein, damit da irgendwer noch mit reingegangen ist, mit Parallelen und man das auch mit dem quatschen können. Wieder rausgegangen.
I'm watching about communications as well. Yeah. No, I mean similar kind of role. Yeah, marketing, communications, yeah. And I've been contracting with the team. Yeah. I wanted to ask you what the stage was. Alright, you do that. Okay, okay. Nice to meet you. Yeah.
Okay, we start in 2 minutes. So, we start in 1 minute. So, we are going to start now.
Record its own what it intakes from the art museum, and has
alles noch ein paar Jahre hin.
Die meisten speichern ja irgendwie mit Zertifikat Hash rein und sagen, jawohl.
We can't see the live stream now. I can't see the live stream. Why is the live stream not?
Immer die Frage, das sind zwei Fragen.
It sounds good.
Yeah, you want to turn it off on the television.
What's your magic trick? So you did nothing.
dynamics decide the need. The trap is to think everything has to be very intelligent. If we look at science fiction, we always say this kind of artificial intelligence and artificial life. Always very intelligent, high-class robots. But how intelligent is nature itself? Nature itself consists for 95% of plants and single-cellular beings. This is not 95% of the numbers, but 95% of the biomass, the dry biomass, carbons. And without this single-cellular life, and without these plants and trees, there was no life. Even we, as human beings, we carry along trillions and trillions of single-cellular life, bacteria. Without we cannot live, we cannot be. And to think about the next steps and Nature 2.0, we for an ecosystem which can fulfill this high standard of nature itself, we always have to think about these small, single task, simple robots. But how do the small robots work together with a very high intelligent robots? So you have the small ant-like robots who can do just a single task, and who what they work together with the hyper-intelligent robot. How can they work together? If we look at the Buddhism says all is life and life is all, and life flows through us, and it's like a field going through us. If we imagine some kind of field where we say everything that as input, every contract, every smart contract, every need, every possibility is a ripple in the field, and all those ripples influence the field like a sea. And the natural state is a flat state, but every time a wind comes, a ship comes, rain drops, everything, the field is changed. And now imagine this: we just decide that the lowest point is the best point to go. So we can follow this field like a marble rolling down the field to the lowest point. And everything we think, well, we have a need, we make a hole in the field. And if we say we want an obstruction, we put a wall in the field where the marble cannot go. In this way, you have a very simple decision model, because the node, the agent, only has to decide where to go to the lowest point and where not to go the highest point. But the input can be very variable. For an ant-like machine, it can be very near its vicinity. It can have very poor sensors, which can not look very far away, which cannot detect light, which only can follow chemtrails. But the more intelligent node agents, they can see the whole universe. They can see the whole of the Earth. They can see They can have millions and millions of types of input, more than we human being can have. Now look, how can that work? Let's take a very simple example. This moth has only two goals in this situation. He wants to go towards the light, because moths do like light, but he doesn't want to fly into the flame, because then it gets burnt. So he gets an objective to go towards the flame, and he's got an obstruction to stay away from the fire. If we plot it in a field, we get the objective to go towards flame, but once he gets near to the flame, he gets this obstruction. And in this situation, it only has to go in the donut shape around the flame, and he rolls like a marble in this donut and makes circles around the flame. This is what moths do in real life. They want to go to the flame, they don't want to get burned, so they fly little circles around it. With two simple input variables, you can make a complex behavior in such a situation. If we make a more, if we convert this to robots who deliver, for example, parcels, we can say, well, we don't want to bump into other parcels, so we make a bump over there. We want the parcel to be delivered in this direction. You can imagine the delivery point is over there, and the marble starts rolling down the road. At that moment, his environment is changing. His environment is the hole is moving towards his end goal, and at the end goal, there is his contract to fulfillment of the delivery of the package. But in the meanwhile, he can encounter something like a river, and at this river, he can decide, well, I can drive around it, but it will cost me a lot of energy. But I can also decide to post an incentive in the field and say, I need to go this direction, and if you make it possible for me to go over the water without crossing around, it will deliver. I have tokens for it to fulfill this contract, and maybe some drone will pick him up, or there are bridge building robots nearby, and they build a bridge for him. So at each time it can decide and it can interchange to fulfill its goal. Now, this is a step in our thought to eventually make magic possible. And if we look at the evolution part, at the current day, if you go into a factory, you see caged robots. You see robots that are not safe for human being. You cannot come close to it. They are programmed to do a single task. They build an automotive robot, for example. They build a part of your car. They are programmed to do an exact movement. They are put on, they switched off and switched on. And gradually, we are moving towards robots that are safe with humans and they cooperate with humans. Nowadays, if you go to the big industry fairs, you see, they call it cobots, that are robots you plug into a table. They can work together with you. They are safe for human beings. You can train them very easily, but still they are trained. We train them to do a single task, and we repeat them like 100,000 times. If you let robots decide themselves, and if they could make own decisions, they can emerge, and they can emerge to a level where they are individuals around you, surrounding you, helping you in a manner other human beings could also help you. For example, with the dishes, or the autonomous system, where a robot designs art itself and sells it on the market. These are autonomous bots, or autonomous agents, who work in a system together with human beings and together in one ecosystem. Now for the magic, if you evolve this further on, the There are all kind of techniques already available, like digital dust that moves, that takes in other shape, without based on an incentive you give. And most of the time it's energy what you give, but you can also give them a chemical reaction when they change. And by controlling these digital dust, you have nano robots that are smaller than single cellular life, and they can all work together on the same simple decision model, where you can where you put in a contract for what I need. And I will give you an example. If you, for example, wanted to like a cup of coffee, if I want a cup of coffee now, maybe a waiter is putting in his machine. Table 1 needs a cup of coffee. Then over there, a cup of coffee is made. Somebody is picking it up, is bringing it here. With the emerging robots, maybe a butler robot will pick it up and bring it over here. But in the nanoswarm robot, you punch in a hole in the field. The field needs to be filled. Maybe there are, on a molecular basis, you can generate a cup of coffee. You can generate the liquid inside and pour energy in it. If all those parts work together, all this technology already available, if you can make this work together, you can really create magic. How to spark this up? We competed last year in the blockchain hackathon for the machine-to-machine ecosystem. We created this field ID, this decision ID, with contracts on the blockchain, where you can decide how to negotiate with each other. We made a little simulation around it, where you actually can have robots running around. They don't want to bump into each other, but they want to deliver the packages. So they, I just flew in for this presentation. I saw the robots are not running, but over there you see the decision-making model. You see they don't want to bounce into each other. They want to deliver packages, so they can decide themselves how to deliver robots, the package. This was done by the team called Team Oddbot. Nowadays they are actually building robots. They are running in a very limited ecosystem, where they weed, where the agriculture robots, they weed like along the plants. They take out the weed autonomously in a field of crops, using this ID and using this AI technology. Well, these are my thoughts about how you can make decisions based on very simple and very expandable IDs. I don't know if there are questions.
What is the interaction between the robots? How do they exactly, what's the communication? Do they work on feedback from each other, or on coupling, or?
The question is how they communicate the robots to each other. It's a very good question, because this is where the blockchain comes in. They put in as a human being, as a questioner for the field, I put in my needs. I want this cup of coffee, for example. But everybody can put in their own needs, and the needs are put in on the blockchain. And by putting it over there, I don't know how it's going to be solved, but I know it's going to be solved. So another robot, another agent, is picking up this signal, this disturbance in the field, and he will be willing to fill up the hole that is generated. And based on the technology it has, it can pick up the signal or not. So some signals can be picked up by the example of the robot coming near the water. If you cannot build a bridge, or you cannot put me over the river, there won't be an incentive for you. So you won't react on this on this question. But if you are a drone or you are a bridge building robot, you're gonna act at that moment on that incentive. It's actually the same as Dimitri showed us this nice picture of ants doing a very complex task, towing a huge amount of plant with each other. All those ants are just reacting on chemical responses of each other. There's no thinking about it. They don't decide themselves, well, we see a very big object, how can we transport it? They just act, they just do it. There is no thinking about it. And the goal is, if you're going to be if you're going to build an ecosystem, not all agents are going to be able to think about what they are doing.
Yeah? Yeah, nothing, right? Oh. Have you heard like from complexity science and attractor landscapes or this, or attractor landscapes?
Actually, I'm not the very technical. The AI guy is now standing at the with his robot on the agriculture event today.
Okay.
So I cannot answer your question if this is from one methodology or not. But the idea is emerged about energy trading between vehicles. That's where the idea originated from.
Okay, interesting. Maybe we can talk later. I would like to talk with him then. Yeah.
Okay.
Thanks.
Sorry. We will now have a wormhole session. The famous wormhole session we talked about. And this is the moment when Gertjan goes in a room following Melissa over there. Don't go with your microphone, I do need it. And the ones who are interested in asking questions and interacting with Gertjan, they can follow him and ask further questions to get to know more about his topic. For the rest, we will have a talk live streamed from Berlin, and afterwards there will be a last presentation from Dan over there in the back. Did you take your decision? There is basically a... Sorry? That's a very good question. Very good question.
So, good. Water Hyve. I will turn Amsterdam down.
I propose you get to already go with Melissa.
And the wormhole session is not relevant for us. And for those who have not understood what it is, it was actually an extended Q&A in a separate room. Mea maxima culpa if I have not explained that in detail or in clear enough words to understand. Yeah. So let's give it like a shout out to Libu. Thank you for hanging in there. Yeah, being last on stage.
Thank you for
Very
having
much
me.
Looking for it. And afterwards, we will be here. I'll wrap up afterwards. If you have questions, I'll be here. Yeah, and now join and enjoy him. Do you need your clicker?
It's a little bit like with the techno parties, you know, the best things happens at the end when everybody's tired and the parties.
Best DJs.
Yeah, exactly.
Berlin.
So, first, few words about myself. My name is Liviu Montescu. I am a political economist. Have nothing to do with programming and so on. And I worked in macro political economic theory at in Cologne at the Max Planck Institute, and on environmental policy in Brussels and here in Berlin at the Humboldt University, until I decided that I had enough and I need fresh air and I want to expand. So I took some of the theoretical issues from political economy and philosophy of knowledge into practice. The talk today will be about water hives. And I want to link a little bit the discussions we had before. namely what we just heard from Amsterdam. Our colleague was saying, for example, the insects were not doing something creatively, they were just acting based on a chemical substance. They were acting instinctually. Thibaut von Polkadot was talking about separate blockchains, that they don't communicate one with each other. The very idea of being is of being connected. You cannot be by yourself. You need to have reference towards something. Otherwise, you cannot exist in yourself. Let's go back to blockchain, to what Thibaut was saying. As soon as you have a blockchain which is not linked to some other things, you created an entity which most probably will parasite. Why? Because it's not able to draw energy, to receive energy from its environment. So it will catch, it will be tended to catch energy by force from the outside. I won't go very deep in this. You can follow some of my thoughts on Medium. There was an article, The Great Transformation. So being means belonging to something, being in relation with something, and means also to contain something. Once you are connected, you exchange information, no matter what that is. The ants exchange biochemical substances, whatever, and based on this they act. So to be is to belong and to contain. Then we have to act. Our colleague from Amsterdam was just saying, they just act. There is no such a thing as just acting. So you are programmed. We are programmed. And to a certain level, we humans, we are programmed. We have our DNA, we have our genes. And as soon as we add acting towards something with intention, then we have creation. We have a creative act. And here we make the distinction between intelligence and instinct. Again, I will not go further into this artificial intelligence. Exactly what do I mean? If you got a little bit the idea, if not, please, as I said, you can follow some of my writings on Medium. Then we have the flow. The flow is be acting and presence. Well, I make few notes because usually I'm nervous and I forget my keywords. It is exactly what I told you at the beginning. I moved from the fundamental research to applied research because I wanted to expand. Be acting means to expand. To put it very simple. And presence means be acting and knowing that, or expanding and knowing that you expand. Knowing where you are at and knowing what you are doing. So these are three categories I'm going to follow in a empirical example, which is my project now. I'm founder at Puraquo, where I was thinking at the following, okay, from a very pure economic perspective, how can we bring money into natural ecosystem restoration? And for this, we need several things. We need data and we need a good communication. So in other words, we need to show that there is, and we need to act. I took one of the problems, like if you go to the doctor and you want to see if something's wrong with you, what you do first thing, you take a blood test. If you want to see how is the state of certain natural ecosystems, what you do, you look at the water. What is the main problem with the superficial water we have nowadays? The nitrate pollution. 70% of the pollution of the surface water on the planet comes from agriculture. Okay, so this is the problem. Now the water companies which gives us water to drink, those of us who still drink from the tap, they have high costs and they really struggle with this. In dry season, up to 9% of their operation and maintenance costs is only for getting the nitrate out. They think about paying the peasants, the farmers, sorry, to use fertilizer more consciously and to lower their in Germany we call it Gülle. Gülle is this basically shit and so on from the cows, right? So to lower this, but it doesn't work. Why? Because they don't have the monitoring. Yeah, they don't have monitors, a system of monitoring in place to know how much nitrate is decreasing or not. Or they just spend 15 million US dollars for a reverse of osmosis unit. So our solution is this, is a water quality cascade sensor monitoring system. We follow the water. We follow the water in its flow, following the hydrological model, and we dispose sensors following the creeks and the rivers, and with this we isolate the farms. And we can see how much a farm is polluting. So how does it work? Quite simple. We have a again I forgot a word. Basically above, like a sensor or a group of sensors, the farm, and downwards, and we can see the quality of water upstream, this is the word, and downstream. And this, then it comes the next farm and the next farm. Here is the beneficiary, sorry for the colors, the water company, the state as well. So what is happening, we have these sensors or clusters of sensors which are placed by combining three models. The hydrological model provided by the water company, the digital elevation modeling we get from the satellite, and the economic modeling we will have from the farmers themselves. That means we need to know what kind of plants they are cultivating, how much, and what kind of cattle they have, how many. Now, the sensors are sending the data per 15 minutes, per hour, whatsoever, depending how are we going to power them. Are we going to power them solar? More often, are we going to use battery 6 hours a day? Every 6 hours, sorry. Sending it to a curation registry, basically, which only shows which one of the sensors works and how it works, like if it is in the parameters. Collecting server, we batch a score per day. According to that score, which is actually the KPI, this score will be compared to the KPI that the farmer himself sets. He will say, I will use this amount of fertilizer, which is translated in that amount of nitrogen. Then we compare it. How much are you? Above or below this? And if you stay below that, you will get prize, you will get money, you will get paid. And this is how we incentivize him. So we don't punish him, we incentivize him to keep his word. Then the water company receives the digital units of service and the physical units of service, the pool of the money, right? So the payment can be done by day using API, bank connection, or using tokens, whatever. This is not a problem. Yeah, basically the market is like this. There are 1.23 billion euro spent in European Union. We address first the European Union market. alone for the nitrate. So, of course, we are customer-oriented, so we are doing here business. We aim to a reduction of the operation and maintenance costs up to 9%. The product will be, of course, tailored for the partners. And then we will have a lot of data on water quality from agriculture, which is another story. Where we are now, we are in the market validation, trying to, it's very possible in the following month to get an LOI with a Riva from the Netherlands. Hello, Netherlands. Are we connected? I don't know. Are we? All right. Which is a water association of water companies, or with someone, I will not tell the name, in Germany, in northwest Germany. In the Netherlands, they have real problem with Gülle, with this, cow shit and so on. They are falsifying the numbers there. They really have bad problems. Okay, prototyping in spring. With the sensors on the market are quite expensive, so we want to make some improvements here as well. We met today with partners from Fraunhofer to develop a more suitable sensor which will be addressed specifically for this problem, so measuring only nitrate. We will use optical sensors, so no ion selective ones. Yeah, so what else? Yeah, of course, results of the case study and basically being ready to scale starting with 2020. We will develop this, as I said, together with our partner, and it will be profit sharing. He will have skin in the game. This means they will help us to get access to the market, and it will help us with scalability. This is our team. Van working in ecology and research. Yatan worked a lot on accelerators, agriculture around the world, Africa, Ghana, so on. And David, he is like really a sensor guy, the sensor specialist. The water Hyve. This is an interface. The sensors, what we are aiming at, imagine the sensors are placed along the watershed. One valley with its sensors communicates with the next valley, which has its own swarm of sensors. And they will want to be more of them, yeah, to replicate themselves. They ask for, because they are at the basis of healthy environments. A healthy environment is beneficial for both human and for them, because there will be more of them, and having an incremental power to self-develop themselves, to self-multiply themselves. This is the idea. Yeah. Thank you.
This is a 25-second delay, but we can ask questions in between, if you want.
Yeah, very interesting idea. Two questions. One is about the incentivization of the farmers still. If you ask the farmer to put in their own target values, what's the incentivization to not put them too high? And then the second question is those measurement points, like those sensors, how do you get them tamper-proof in practice?
So first of all, there is a Fertilizer Act at the level of the European Union, so they cannot go above that thing. This is most of them, they go way above, way above. In the Netherlands, in Germany, there is how they are doing it nowadays is with samples, using water samples. So this is, and the more if they stay on the limit, They say, well, if they stay below the limit, then the water company makes profit. If the water company makes profit, we can build with the data from the sensors and on our platform water bonds for external investment. We prove the water company is profitable, is getting more in profit. We get more investment from our side. This money will be directed to the farmers who will continue to lower their use of fertilizer. The water company increases in profit, the investor makes profit with a bond, and slowly the agriculture turns towards a sustainable agriculture. Bioproducts, you'll see more of them. The farmers will start to search for other markets. And this is the idea behind. Temper. So we have here the concept of the new tool in the farm. So the sensor, it will be located on the farmer's land, and they will do the basic maintenance work, which means basically cleaning the lenses or so on. And now on the data that we receive, here we couple with the hydrological data we have, and with the we don't have only the sensors in the water. We also have rainwater sensors to know how much water we get from the sky, because we aim at not the percentage of nitrates in the water, but of the amount. And this will be tempered together, yeah. And I can't say you right now exactly how we are working on this. And yeah.
Okay, the wormhole session, yeah, where you can get Livu. He doesn't have to go into this room, yeah. I would just say, like, step up. Sitting is not healthy for such a long time, yeah. Let's grab one last drink, enjoy, say thank you for the presentation, yeah. This is actually...
Thank you for having me.
Yeah, this is actually Cryer, and this is actually working live streaming, so this is what's happening in Amsterdam right now. Once again, I'm Stephanie. I work for Nature2.0. We are a community of communities. On the 28th of January, you can sign up for the hackathon, yeah, and you can sign up for the challenges. There are a lot of challenges, yeah. We have the most ambitious track, the Nature 2.0 track, where we do the buildable but unimaginable, like Livu is doing. The hackathon will take place on the 11th of April. We're having another meetup on the 16th of January. We're having a Telegram group you can join. We're having the website that you can look at where you can contribute. Yeah, and if you want to co-create with us, just approach me. We love to co-create, and we love to have all of you on board. And we believe in that. And thank you very much for your input.
Thank you.
I leave the live stream on, yeah, and just let's mingle.
目的就是为了一个进农人，对啊，然后农业成本是低的，你知道吗？怎么负担起？我要最后比较一个钱，但是这样，我已经反对